Hey guys, so I've been meaning to make this video for a while now. So throughout the entirety of my robotics career, I've basically exclusively used SolidWorks. But as anybody who's used SolidWorks, SolidWorks is very particular about how you do things, and there are certain ways that you can do it that's right, and certain ways that make SolidWorks very angry. So some years ago, I kind of did a lot of my own research, and I also kind of collaborated with some fellow Leatherbacks members, and we've kind of devised a system that pretty much all of us use in SolidWorks in order to CAD robots. And I've come to a stage where I really need to be teaching a lot of newer Leatherback members as well as Honeycracked members that use SolidWorks how to use this method. So I really just wanted to make this video just to put all my thoughts into one video so that I can stop explaining it every time. I can just be like, hey, look at my video. So this is kind of how most people go about doing their CAD. This is like using no like fancy stuff or external references or anything like that. So, you see, this is just an example, but you can have your main assembly and your sub-assembly, and, you'll CAD each individual part separate from each other. But I'm sure as everybody, who has ever CAD'd anything before, especially a combat robot, where literally every single part is completely custom. We're typically not doing like a standardized bolt pattern. Everything's custom, Every part, for the most part, the geometry of it depends on another part. So it's like counting them individually, as, you often would learn to do, is pretty suboptimal. You can waste a lot of time, and like, especially when you CAD one part and you CAD another part, and guess what? Maybe the dimensions need to change. You don't have to change both of them. So what a lot of people end up going to is they're like, there's this thing called external references, where inside of an assembly where I have all the parts together, I can actually just, edit the geometry in the sketch, and I can, have one part depend on other parts in the assembly. However, while it seems great at first, that is really not the approach that we are going to want to take. And there's a few main downsides when it comes to it. So the big downside is the fact that we basically create a loop here, where the part is dependent on the assembly, and the assembly is dependent on the part. So it's very possible that we have the part in the assembly, and the part has geometry that references its place in the assembly. Well, what happens if, the geometry changes, and it changes its position in the assembly, which then, changes what the assembly is referencing, or what the part is referencing in the assembly. And now we have this like paradoxical thing where, your entire model can just explode, and then you'll be really sad because your model will be break. And sometimes it can be like even unrecoverable. I've seen that before. I've heard a lot of people that have, used external references be like, oh, the CAD model just got so bad, we literally just had to export everything as a set file and then re-import it and then just work off of it from there. So we don't want to do that. That's not like a sustainable model, So this leads me to the way that I've been CADing for probably a little over 2 years at this point. And the method is the multi-body, or I guess master part method. I don't really know exactly what to call it. But anyway, here I've made this diagram so you can see. So inside of this part file, instead of having, an assembly with a bunch of parts, you have a part file with a bunch of bodies. And each body can individually represent a different part. So you CAD them together so that way they can all reference each other. And then you can export the parts and then put the parts into the main assembly. Now, you may be asking yourself, why is this better? So the main reason is because it is more stable, and it is also easier to work with. It's a lot more organized. So it's a lot more stable because if you look at the diagram, all the arrows start from the bottom and they go to the top. Everything goes in a single direction, which means that, you don't risk this paradoxical relationship between parts. Additionally, it's a lot easier to keep track of and stay organized because you know that anytime you want one part to reference another part, you do that in the master part. anytime you want to add any of these individual like details and refinement to parts, you do that in the part file. Or if you want to be 100% sure that a change to a part doesn't affect any other parts, you can do that in the part file still. And then everything comes into the assembly and everything plays nice. So what we're looking at right now is the multi-body master part for a newer CAD that I've done. This is Reaper, the undercutter part of the Honey Bombers. It just competed at June. It did pretty well. I'm very happy with it. But specifically, I want to talk about the multi-body part. So typically, whenever you're starting, well, whenever I start a CAD, one of the main things that is nice about the master part is you can start off with your sketches, your master sketches, which basically define like the entire structure of the robot. Essentially, like what we're trying to do, or I guess the methodology behind this, is that, you know, whenever you start a CAD, a brand new robot for the first time, like you don't really know how it's gonna go. You know, like generally it's like I kind of have a general idea of like what motors and what, you know, like gearboxes I want to use, and maybe like how big the weapon is, and kind of general idea of how I want to do the setup, the weapon setup and such. But like I don't know what the robot's gonna look like. So by doing it this way, like we start with our sketches, we can basically make all of these features dependent on these sketches. So that way we can, you know, maybe we realize that, oh, we want the wheelbase to be a little bit wider, we want to bring the weapon forward. We can just edit the sketch and then it corrects the entire model. So here I started out with the top sketch. You can kind of see here where I kind of put in like what I thought my weapon diameter is. I made just some boxes for some gearboxes, the gearbox, drive gearbox, the wheel, the like hub, and kind of like the geared setup. I did that dimensioning here. Basically just, you know, things that I could like figure out now. I'm just trying to waste as little time as possible to kind of, you know, figure out the general layout of the robot itself. And then here I've got the side view. And once you do one view, you can make one view dependent on the other. Like for example, I made this wheel, the diameter of the wheel, dependent on the diameter of the wheel that I established in the first sketch. So you can kind of like better see how things, you know, connect together and, you know, in 3 dimensions. So I can also kind of see here, like, oh, there's kind of the space that the weapon's going to take up. You know, is this enough height for the motor? You know, basically I'm just trying to figure out what I don't know and get a better idea of like how I'm actually going to go across doing this model. And I guess I'll just give you, like, show you what I just generally did for the tree. You know, I just kind of went down, I did the weapon structure, the TPU, like, chassis. Another thing that I often like to do in master parts is if I know that the robot's going to be symmetrical, I'm only going to CAD half of the robot and then I'm going to mirror it over. I feel like this is a pretty common thing. There's oftentimes a lot of CADs where it's asymmetrical by design, so I can't do that. But here, it's completely symmetrical, so I'm just going to CAD half of it and mirror it over. So here we got that, put in the top plate, you know, put in the snout, the wheel guard. So the general thing when it comes to like doing these bodies is, you know, here, let me scroll back. So I CAD'd this. So this is the first, you know, body that I made. This is like the weapon structure. And then I wanted to make another body, which is this. So whenever you extrude something and you want to extrude a new body that isn't a part of an existing body, you just gotta unclick this little checkbox here, which is merge result. If this is checked, then it'll merge them together, assuming they overlap. If not, they don't. Now, okay, so I actually technically didn't have to uncheck this here because these bodies aren't connected, but generally it is still a good idea to uncheck it if you know that you don't want them separately, because sometimes SolidWorks will like randomly combine a whole bunch of parts together in a way that you don't like. So, yeah, do that. Here is like my big mirror. So you can't, I have 2 different mirrors, and the reason for that is because this mirrors, there's this little checkbox that says merge solids, So this mirror is for everything that is like mirrored, that like the individual part is mirrored to create like another half of the one part. So that's that mirror. And then this mirror is all of the bodies that don't combine. Technically I didn't need to do that, and I'll show you why later, but I like to do it anyway. Yeah, so this is the multi-body part. So another piece of advice when it comes to making symmetrical parts and mirroring things over is choose, whenever you start your CAD model, choose either the left or the right side to be your dominant side, and always start from that side, because here you can see in Reaper I chose the left side, and once I CAD'd everything on the left, I mirrored it over to the right. And basically what that means, or sorry, what you want to avoid is starting on the left side and then mirroring stuff over the right side, and then maybe doing stuff on the right side and mirroring over to the left side. Like, that can get kind of weird and wonky and break stuff, especially if you need to, you know, like delete a mirror and put it in later. Like, it can get wonky. So I recommend just choosing a side and sticking to it. Finally, something you may notice is that everything is nominal and there's basically no fillets here. For the most part. I have a few fillets. Wait, no, actually I don't. But essentially, inside of the master part, I want everything to be, it's like, you know, it's true nominal value, because the whole point of the master part is each part, or as a body right now, is in a state where it can be easily referenced by other parts in order to, you know, construct the full model. So I don't want like the value, like, oh, like in reality I usually like trim a little bit off of each of the top plate in order to make sure that it fits, but like I don't want that here. Whenever I'm referencing stuff, I want it to be the actual value. So this basically creates an environment where you can do that, and you know, like 100% you are referencing the true value. Okay, so now we have the multi-body master part. Now what? Once we have the multi-body part, basically all you have to do is, I've just made a new part file here just to show you. Of course, I've already done this, but earlier I said that we kind of export the parts, but that's not technically true. Technically, we're not exporting them. We're importing the master part. So what you got to do is you got to go to Insert, Part, and here you can see this is the name of the multi-body part. Now, it's very important that when you import it, don't like I can technically move the part around here. Don't do that. So by just clicking the check mark and not moving it around, yes, I don't, that doesn't matter. So by just clicking the check mark, basically what we've done is we've ensured that the right plane of the part file is aligned with the right plane of the master part. And this is important because, you know, symmetry is important. And if I want to like mirror or do any sort of mirrors or fancy stuff like that, I want everything to be perfectly aligned. Okay, so the next step, once I've imported the master part into this other part file, now all I need to do is I need to go to the mesh modeling tab, and then delete keep body. And now you can just keep the body that you want. Like, let's say I want to keep the snout. This is going to be the snout's part file. I just click check, and look, now this is just the snout, and I can do whatever I want with this and refine it before it goes into the assembly. So here you can see this is what I had for the finished snout. Like, I added all these fillets and stuff like that. And again, just to reiterate, it's nice to have the fillets and random stuff to make it look pretty here, because this way it doesn't clutter up the master part. Another thing that you can choose to do is you can actually have, you know, you can keep multiple bodies in the same part file. There's different reasons you may want to do this. The main, so like in here, I have all of like the TPU chassis in one part file. The main reason that I usually do this is because I'm lazy, but you also, maybe you want to still be able to reference them opposed to each other. But anyway, here, like, I went in, I put all the fillets, and yeah. Another very common thing that I do in the individual part file is if I know a part is mirrored, I make the mirror version in the individual part file. So earlier I said that technically you don't have to mirror it in the master part. That is technically true, because in the actual assembly, the mirrored version is in the same part file. So if I go back in time, the only body that I kept is the left wheel guard, and then I add my fillets, and then I just mirror over the body, and that's what goes. This is the part that goes into the assembly. And the reason that you'd want to do this is so that way you only have to do all of your fillets and fancy stuff once. So it's just gonna save you time in the long run. Okay, so the last thing that I wanted to show is getting the parts into the assembly. So here I've got, I made a new assembly, begin assembly, and there's all these the parts. I'm just gonna put a few of them in here just for example. But okay, so let's say I want to put the snout in here. Literally, what you're gonna want to do is click the part that you want in, and then hit check mark without moving it around. Same way that you put the bodies into the individual part file. Okay, so basically what this does is it fixes the part in place, and the planes of the part are the same as the planes to the assembly. Here, let me do another one. Just for example, here, TPU chassis. Just gotta click check mark and it's in here. Now, you may be able to see the utility of this. Because we CAD'd everything in the master part, everything keeps its reference in its positional reference to the cardinal planes, which means that whenever we import it into the assembly, it's already in the correct spot. Now, it may just seem like, it saves you a little bit of time now, but it can actually save you a lot of time in the long run as well, once the model becomes more complicated, by the sheer factor that the part's position is not dependent on mates, which means that you can completely change the geometry of the part, and the part will always know where it needs to be in the assembly. So you don't have to worry about like mates breaking and it being all wonky and stuff. Like the part knows where it is because it is correctly referenced to the cardinal planes. All right, I've got the actual main Reaper assembly pulled up here, and I just kind of wanted to show you the general structure. So this is where it kind of, comes up to, it's up to kind of personal preference. I've seen different people do it in different ways, but I like to have a structure assembly. Mine's my terrible G10 pattern. SolidWorks is stupid. But here I have like the general structure assembly, and then I put the structure assembly into the main assembly. And then here I can put in all the different like hardware and components and all that shebang. So here we are able to do the majority of the robot's structure inside of the multi-body part. Now, I want to say that not every part of the robot, I think, is best CAD'd inside of the master part. I think there's still certain parts that you should CAD individually. I think that one of the bigger examples of which kind of part should be CAD'd individually is the weapon. So here you can see that I have a separate weapon assembly, and different things like the weapon blades are CAD'd individually. And I like to do this primarily because a lot of my different like weapons, and I think wheels is another one. I think wheels need to be CAD'd separately. I like to copy them and move them around between different like either versions of the robot or different CADs. So I really don't want my weapon to be parametric with the rest of the model. I want to know that, whenever I have a weapon, it's, set in stone, it's not going to be messed with. And part of it is like, because the dimensions of the weapon are just so critical to the robot, both in terms of like weight and space, and also the balance of the weapon. I would hate it if I accidentally dimension the weapon based on some other part of the robot. That part of the robot changes, and now my weapon is unbalanced, and I didn't realize that. Like, I want my weapon to be completely isolated, so I know I cannot accidentally mess with it. But, yeah, that's really all there is to it. Let me know if there's any questions or anything in the comments, and I guess I don't know, maybe I'll do some other videos or tutorials or something like that. This is my first, like, actual video, and it was definitely an experience editing it and stuff. And I definitely learned that I say and so a lot, you know, a lot more than I would have thought. But yeah, I'll catch you guys later.